This video is about polymers, but we will also review the other chemical reactions. Now, polymers are long chain molecules, and they are made of building blocks called monomers. Now, they are made of individual repeating units. So you have like this one thing here that's connected to this, and each of those circles represents a monomer, right? And you learned about this last year. There's a lot of natural polymers. For example, starch is made up of a bunch of glucose molecules that are connected to each other in a chain-like fashion by dehydration synthesis. In nature, there's lots of polymers. Proteins are polymers. Your hair is a type of protein. It's a polymer. It's called keratin, right? Spider silk is a protein. It's a polymer made by spiders, and it's a long, long molecule, okay, that's very strong. DNA is a polymer. So there's lots of natural polymers, some which, there are lots of different types of carbohydrates that have polymers. There's chitin, there's cellulose, there's starch, there's animal starch, plant starch, a lot of different polymers, all right? There's also a lot of artificial polymers. These are things that humans who are scientists have created over the years that serve a lot of purposes. For example, PVC, which is found in plumbing pipes. It's also found in your lawn chairs or any of that hard white plastic that things are made of, like little end tables or like the umbrella thingy. That's all PVC. They can color it too, so you can get, green lawn chairs if you want. But your plastic bags are made out of, you might have heard of things like nylon or rayon. You might have even heard of polyester, which was, okay. And these are all things that fabrics are made of, Teflon's a polymer. It's what your pots and pans are sometimes coated with. So there's a lot of different polymers out there, and they have a lot of different uses. All plastics essentially are polymers, all right? And they are created artificially from monomers that are connected. And the monomers are connected in two different ways, which we're going to get to in a couple of minutes. Now, let's do a quick review of all the other reactions before we get into the final two reactions, which are the two types of polymerization reactions. So here's a picture of all the reactions we've learned so far. And if I was a good student, I would pause this thing for a little while and try to see if I can identify all 7 of these reactions. I'm going to go through them right now, but I suggest you pause and try to do it yourself first before I do it. All right, here we go. The reaction that involves a lipid and a base is saponification, and you get glycerol, which is basically 1, 2, 3 propantriol, and you get sodium ions that connect to fatty acids, which are a detergent. So the first one is saponification. I'm going to be lazy and write sapon. Okay. The next reaction involves glucose turning into ethanol plus 2CO2, and this involves yeast, which is an organism, and this is an example or a type of fermentation. And there's other types of fermentation, but you should know about this particular fermentation. And again, it's very important, okay? It's not just for making somebody's alcoholic beverage. It's used to store things and allows humans to store nutrients, basically, over long periods. And involves that, Anyway, moving on. Okay, the next two are the addition and substitution reactions. You have to know which one's which. Remember, substitution involves saturated, that's easy to remember, and addition involves unsaturated. So if you look at number 4, this guy right here is unsaturated, and you're basically adding the bromines to that. So 4 is the addition reaction, and number 3 is the substitution reaction. Because you're kicking out one of the hydrogens, it's being substituted by a bromine on a saturated hydrocarbon, methane. Number 5 and 6 are the esterification and the etherification reactions. You have to know which one is which. You should be able to look at the products and tell, and you should be able to name them. So this has a single oxygen in the middle, which makes this an ether. Notice it is a dehydration process. So this is diethyl ether, and this is etherification. And the next one, we have an alcohol reacting with an organic acid to make this guy. You can see this extra double bond over here, and that's the O and the OH. So this is going to be ethyl ethanoate. So number 6 is the esterification reaction, and number 5 is the etherification reaction. All right, the last reaction that we have here is the one we learned months ago, which is your standard combustion reaction. And remember, the products don't have to be CO2 and water, but they usually are as long as there's an excess of oxygen around and you're merely combusting a hydrocarbon. If there are impurities, you'll get other products of a combustion reaction. All right, let's talk about polymerization. So there are two types of polymerization. There's dehydration slash condensation, which is one type. They're the same thing. And then there is addition. Let's do this right here is showing you dehydration. And the good thing is you already learned this. In dehydration polymerization, you take monomers that have substituents or groups on the end of them that allow you to make water or dehydrate. And you did this when you made a polysaccharide. You used scissors and glue to make a polysaccharide, probably in your living environment class. So if you take off this OH right here, the hydroxyl from one of these ethindiols, and you remove the hydrogen, and you make water, then what you get is you get this molecule right here. And what you want to notice is this molecule has now the O in the center here, right? This, which is this oxygen right up here, right? And that ends up connecting the two carbon molecules. But what's important about this is now that you've made this thing, you can now do it again. So you can now take this off and this, remove another water, and then you'll have like this OH at the end still, and you have CCO, CCO, CCOH, and you can then add another one to this, and you can keep doing it and doing it and doing it, and you can make a very long molecule with very specific properties. And there's lots of molecules in which you can remove this H and this OH from it. That happens when you do it for amino acids and you make polypeptides. This is just how polymers get made. If you connect six monomers, okay, then you're going to get a chain molecule with 6 monomers, plus you're going to get 5 molecules of H2O. Why 5? Because when you connect 2 molecules, you only get 1 water. When you connect 3 molecules, you get 2 water, and so on. So if you make something that's 100 monomers long, you remove 99 molecules of water. All right, let's talk now about addition polymerization. In addition, it's just what you kind of expect. It involves an unsaturated compound. So you could have 2 molecules of, let's say, ethene. Now, so addition reactions always involve things that are unsaturated, so that will make it easier for you to remember. And in this case, we have is 2 alkenes, ethene and ethene. Now, what essentially happens is the second bond, which is the weaker bond, breaks. And I remember what a bond is. A bond, okay, it really is just 2 electrons, right? It's a pair of electrons being shared. So what happens is one of those electrons goes here from this, and one of the electrons from here goes here as well, and that forms a connection, which is right here. Now, there's still 2 other electrons, and what you can see here is essentially what happened is the double bond that was here broke, and one of those 2 electrons went over here, and one of them went over to here. And so now you've got this extra electron here, but you don't have a double bond anymore in that space. You just have a single bond. And you have this extra electron here and here, which makes this unstable, which means essentially it will try to get the extra electron because those carbons are not stable. They have 7 electrons around them. They're unstable. So it'll happen again. So another ethene will come along and its extra bond will break. And so it'll end up being 6 carbons long with the 1 extra electron at the end and at the end here. And it'll just keep happening and happening and happening and happening. At some point, there'll have to be a reaction that with something else that's present that will stabilize the ends of the molecule. But essentially what you're doing is you have a certain number of these ethene molecules like this, and they just end up connecting, whatever that is, you get up with n number of molecules, all of which are now connected to each other. And the ends, they have to put something on them because they're not going to be stable because they're going to have, basically an extra electron that is unstable. So they'll have to end up connecting to something else essentially, or grabbing a hydrogen or something that is around to stabilize the molecule. In just a quick summary, so you have 2 types of polymerization. You have dehydration, in which water is removed because there's probably maybe 2 hydroxyls at the ends of the molecules, and the oxygen is the connector. And you have addition, in which you break the double bonds, and the extra electrons that were in those double bonds end up forming a single bond between adjacent molecules. So you have a bunch of single bonds now instead of some double bonds. And you always start with unsaturated molecules to make this. That is the end of organic chemistry. And so you'll have an assignment on that as well. Have a good day.